Hello, today we will study how to graph a function. I mean like any function, okay? So I will show you a special way to graph a function y equal to x. Okay, so we just follow this step. The first one, you have to find the domain D. Domain, okay, and range. Okay, the second step, find asymptote of the function. Okay, and the third one, find x, y, intercept. Okay. For find local max and local min. This one equivalent, you have to take the first derivative, that means you take y prime. Okay. And set it equal 0. Okay. Set y prime equal 0. Then show for y prime, so show for x, then you will find local max and local min. And last, find the second derivative. Y 2 prime set equal 0, so you will know the inflection point. Okay, you will know the graph will contour down, contour up to this point. Okay, and last one, you set up the table which include y prime and y 2 prime. Okay, so again, repeat. Okay, in order to graph a function, any function, okay, we need to go to 6 points to graph. The first one, you have to find domains or range. The second one, you have to find asymptote. Okay, you can use like limit or L'Hopital rule to find asymptote. The third one, you find x, y, intercept. And the fourth one, you have to find local max, local min of that function. That means you have the derivative of y prime of that function and set it equal 0 and show for x. Then you will find local max and local min. And the fifth one, that second derivative, find the inflection point. Okay, y prime equal 0 and so for x. Okay, and finally you set up a table include y prime and y double prime. Okay, y first derivative, second derivative. Okay, so let's go to example. Okay, let's go easiest example first. Let's say y equal x squared minus 2x plus 1. Okay, well, we know it's a parabola, but well, suppose you don't know. Okay, now the first step, we find domain and range. So number 1, domain. Okay, this function can have any value of x, so domain equal r. That means the set of real value, and then range. Then also equal real. Okay, and second step, we find asymptote. This function doesn't have any asymptote. Okay, this function is go from infinity to infinity. X from infinity to infinity, so it's not go to, it doesn't have limit to go, it doesn't convert to anywhere, or it doesn't have any point undefined, so no asymptote, sorry. And first one, find local min, local max, local min, or local max. So in order to find that, you must take derivative y prime. So y prime, derivative of x squared equal 2x, derivative of minus 2x equal minus 2, and derivative of 1 equal 0, and set that equal 0. So y prime equal 0 is equivalent to 2x minus 2 equal 0. So this one, x equal 1. Okay, when x equal 1, then, okay, now you should put x equal 1 in here. When x equal 1 here, so y equal 0. Okay, x equal 1, 1, 1, y equal 0. Okay. And, okay. Find the xy intercept. Okay, x-intercept. X-intercept, that means y equals 0. When y equals 0, we have the quadratic equation 0 x squared minus 2x plus 1. Okay, this one have two, well, you can just factor it out. Let's just go x. This one have square root of square root of 1 and 1. It's 1 and only have one. Just have one. I have at the double root as equal 1. Okay. So this one equivalent with 0 equal x minus 1, the whole thing square. Okay, that means only one root, x equal 1. Okay, now y prime. So you have y prime here. So we take the second y double right, y second prime, 2x minus 2. So y prime, y second, y double prime equal, take the derivative here equal 2. Okay, positive. So that means this one can go up. Okay, let's go up. Okay, y up. Okay, now we make the table. Okay, right here, make a table. And then make the table. So here we put y here. Okay, let's put y prime first. And here y, y first here. Y here and y prime here. Okay, and y second prime here. Y double prime. Okay. Okay. When x equal 2, x equal 1, it's 1 here, and y equal 0. Okay. And also here we with x intercept, y intercept. That means x equal 0. We substitute here. Y equal 1. Okay. X equal 0, y equal x equal 0, y equal 1. X equal 0, y equal 1. Okay. And here we have y prime when x equal 1, y equal 0. Okay, and this one y prime equal to x minus 2. So on the left of 1 is negative. Okay, when x less than 1 is negative, and when x greater than 1 is positive. Okay. Okay, so that means this function will go down from minus infinity to 1, and it go up from 1 to plus infinity. Okay, so it go like that. So we know it have the local minimum. Let's go local minimum, and it go from negative infinity, and it go local minimum, the point local minimum, x equal 1, y equal 0, and go up to plus infinity. Okay, now let's graph it. And y second prime equal 2, so it's on way positive. So it means y is on way above x-axis. So y on way has the value of positive. Okay. Okay, now let's graph it. Okay, let's draw this. Okay. Using the table. Okay, let's. Okay, x equal 0, y equal 1. X equal 0, y equal 1. Let's set 1 here. And x equal 1, y equal 0. Okay, so second point right there. Okay. Now let's find one more point. Well, let's say y equal 2. Okay, the function is y equal 2. Oh no. Okay, x squared minus 2x plus 1. Okay, so y equal 2, x equal 2, 2 minus 4. Okay, minus 4 plus 1, 4. So plus 1. So x equal 2 right here. It's 1. And y equal 1. 4 minus 4 equal 0, and you have y equal 1. So this point right here. Okay, so we know the function will go down, and this point right here with x equal 1, y equal 0. This point is local minimum. Okay, so by the graph, we know this one negative, this one positive. By y prime, and we know the function will go down from negative infinity and hit to the local minimum, this point right here, and then go up. Okay, so we draw that. This is the parabol. Okay, so right here is since it touching the x-axis, so this point is called double root of the function. Okay, and here we have the intercept, y-intercept at x equal 1, y equal 0. Okay, so we're done. Okay, this, when we use this table, you can draw any graph, any function. Okay, let's go and let's do another example. Try something a little harder. Okay, let's say y equal 2x plus 1 over x minus 1. Okay, first one we have to find domain and range. One have domain. Okay. Domain x. Okay. We have denominator here. X equal x minus 1 cannot equal 0. So domain has to be on value except x equal 1. Okay. And range and x can be and y can be any value. Okay, so actually it's a find domain. You have to find range. So second one we find asymptote. Okay, this function, since when x equal 1, then this function y undefined. Okay, so you have we have like when x equal 1, you substitute here. We have top the numerator 2 times 1 equal 2, 2 plus 1 equal 3, 3 divided by 0. Okay, so y go to infinity. Okay, so x equal 1. X equal 1 is vertical asymptote. Okay, now if we have this function is the quotient. Okay, with the top and the bottom has the same coefficient. So if you apply Hospital rule, you have limit of 2x plus 1, x minus 1, and x go to infinity. Okay, so we have infinity over the infinity. So if we take the derivative of top and bottom, then we have 2x plus 1 derivative, apply Hospital rule, and bottom x minus 1, x go to infinity. Then you will have limit of 2 over 1 when x goes to infinity, so equal 1. Okay, so when x go to infinity, then y equal 1. Y equal 1 is the horizontal asymptote. Okay, so we have x equal 1. Okay, x equal 1 and y equal x equal 1 vertical and y equal 1 is one vertical asymptote, and y equal 1 horizontal. Asymptote. Okay, so and now we find number 3, x, y intercept. Okay, so y equal 0. We find x intercept first. X intercept that means y equal 0. Y equal 0 that means the top equal 0. So we find x intercept. That means y equal 0. Okay, one x intercept is y equal 0. Y intercept and x equal 0. Just converse x and y. Okay, y equal 0, then that means 2x plus 1 equal 0. That means x equal minus 1/2. Okay, and when x equal 0, y intercept. So we use y intercept. So when x equal 0, just substitute x equal 0 on here. You have 1 divided minus 1. And y equal negative 1. Okay, so as a y intercept. Okay, so now we need to find local max and local min. You have to take the derivative of this. Okay, let me draw it. Okay, so x intercept y equal 0. X intercept at negative 1/2 and 0 and y-intercept x equal 0 and y equal -1. Okay, let's erase this so we have more room, more space to make the table. Okay. Okay, take the derivative of this y prime. Okay, we have quotient. You can apply quotient rule for the derivative. So the derivative of the second one, x minus 1 times 2x plus 1 minus, okay, v prime u minus u prime v. Okay, v is the denominator, v is numerator. Okay, so u prime is 2x plus 1 prime times with u x minus 1. Okay, the whole thing divided by v square. V square in this case equal x minus 1. To divide by x minus 1. Okay, so let's simplify this. So x minus 1 derivative, so equal 1. Okay, so 1 here is multiplied by 2x plus 1, and the minus derivative of this 2 minus 2x plus 1, derivative of 2x is minus 2. 2 with minus in front, so you get minus 2 times with x minus 1. Okay, the bottom x minus 1 square. Okay, and this will be equal to 2x plus 1. Multiply out and then just simplify and multiply this minus 2x plus 2 minus 2x plus 2 over x minus 1 square. Okay, so 2x cancel with minus 2x. So it equals 3, 1 plus 1 is 3 over x minus 1 square. So, okay, y prime equal 3 over x minus 1, the whole thing square. X minus 1 square is a positive number, right? Greater than or equal 0. Okay, and 3 also the positive number. So this function it always go up. It doesn't have local min or local max. Okay, so this one doesn't have local min or max. Okay. Okay, so okay, let's draw the table. Okay, here we have 3. It's only positive. So we have a y prime equal 3 over x minus 1 the whole thing square. Okay, so you have like, okay, you have here x, here y prime, and here y. Okay, from 0 infinity, domain from negative infinity to positive infinity, and x cannot equal 1. So when x equal 1, okay, then y undefined. So when the function defined, use this notation. Okay, 2 line parallel. Okay, and then when x equal 1, okay, this one vertical asymptote and y equal 1. Okay, and this function when x equal or 1. Okay, and then use x equal 1, x equal 1, y equal, no, x equal minus 1/2, y equal 0. Okay, and x and y, this one, x equal 0, 0 here, y equal -1. So here -1/2 and -1. Okay. So here 0, -1/2, 0, and 0, -1. Okay, so from the function on way going up, let's go this way. Doesn't have local min, local max. Okay, so we know it's go this way. Okay. Can I drop it? Okay. So here we have x equal 1. Okay, that's the vertical asymptote, and y equal 1. It's right here. 1 right here, and 1 here. Okay, and we okay, so we know when x equal x intercept. So we know this function going up. So it cannot go this way, okay? It go between these two lines, between x and y. This one x equal 1. This one y equal 1. Okay, so when x y intercept, when y intercept x equal 0, y equal -1. X equal 0. Y equal -1. Okay, and x intercept. So we have x intercept. X intercept y equal 0. So that means when x equal -1/2, x equal -1/2. So the first line go like that, and the other side. So y the other side. Since it's only have one intercept, x and y right here, so it's not crossing x here or y here. So it has to be in this corner. So it has to be this way. Okay, because if you roll this side, it will cross x. Okay, and if you go this side, it will cross y intercept. So this is the hyperbola of the function y equal to x plus 1, x minus 1. Okay. Alright, so let me summarize. Kind of like complicated, but you need to practice to get used to this method. Okay. Okay, on the table here, this one, the first value is x, and you have y prime, and you have you can have y second prime if you want. Okay, and here y. Okay, from the domain find domain. Okay, and then find local max and local min. Okay, so local min or local max. At local min, at the point local min and local max, then y prime equals 0. So for 0 here, okay, and from from x to local min, you have to consider the sign of y prime. Suppose it's a negative, and when positive, it's a negative. Okay, then y will go down, go up, and go down. Okay, so to get more point in the graph, you need to find x and y. So x-intercept, you need to find x-intercept, and y-intercept. Okay, so put more point here, so here, and get the value of y right here. Okay, and also you after that you can find y prime, so you know the graph will concur up or concur down from what point to what point. Okay, and finally you put the if the function have asymptote, then you have to throw the asymptote. Okay, so it's pretty simple if you really get used to this, and I basically use this to draw any map. Okay, use 6 basic point to draw any map. Okay, so next time I will talk more detail in this method. Okay, all right, so see you next time.